A community built with 3D printing technology is producing one house every week for a year. 3D printing technology has been slowly but surely gaining traction as a viable construction technology, with communities of 3D printed homes being built in California, Virginia, Texas, and Mexico, among others. Now, a new development on the other side of the Atlantic is joining this list. 14 Trees, a joint venture between Swiss sustainable construction company Holcim and British International Investment, has announced the completion of the first 10 units of a 3D printed housing project in Kilifi, Kenya, called Mvule Gardens. Mvule Gardens is set to eventually consist of 52 single-family homes. The first phase of the project includes 6 3-bedroom houses that are 836 square feet each and 4 2-bedroom houses measuring 616 square feet. The printing process started in October 2022, with the goal of putting up the walls of one house each week for 10 weeks. According to Holcim, the walls of the 2-bedroom homes took just 18 hours to print. The technology behind the project. The printer being used for the project is a BOD2 from Danish company Cobod. The company claims that the BOD2 is the fastest 3D construction printer on the market, laying down 1 meter's worth of material per second. The gantry-style printer moves between 3 axes on a metal frame and requires 2 human operators to run it. The BOD2 was previously used in 2020 to print an apartment building in Germany and in 2021 for a school in Malawi. The location and affordability of the project. Kilifi is a town in southeast Kenya, located on the coast about 35 miles northeast of Mombasa. The prices for the 2-bedroom houses at Mvule Gardens start at 3,610,000 Kenyan shillings, which is approximately $28,620. While this price would be considered affordable for the average American, it's less so for the average Kenyan. However, 14 Trees has stated that one of its main goals is to continue lowering construction costs with each phase of the project, ultimately offering homes for 20% less than standard houses. Moreover, the 3D printing technology used in construction allows future homeowners to design their own floor plans, taking advantage of the customizable and modular nature of 3D printing construction. The housing shortage and the potential of 3D printed homes. As you've probably heard, or perhaps experienced firsthand, there is a massive housing shortage not just in the US, but all over the world, with millions more people in need of homes than there are homes available. The best way to solve this crisis is to build, but we have to do so in a way that's smart, sustainable, and affordable, not to mention fast. According to 14 Trees, there is a deficit of nearly 2 million homes in Kenya alone. While there is some debate about whether 3D printing is truly a viable and scalable solution to the housing shortage, 3D printed communities offer a promising alternative to the current lack of affordable housing. Critics point out that the cost savings likely won't be as significant as all the hype implies, nor will the eco-friendliness, since the homes use cement and cement is a major source of carbon emissions. Additionally, 3D printing is most practical for single-family homes and less applicable for the dense, multi-story housing that will go furthest in closing the supply gap. Conclusion. Despite the potential challenges, the completion of the first 10 Mvule Gardens homes is a significant milestone for 3D printed housing and sustainable construction. This project demonstrates the potential of 3D printing technology to create affordable and customizable homes in areas with housing shortages. With the use of a fast and efficient 3D printer, the construction process for Mvule Gardens was completed in a fraction of the time it would have taken with traditional building methods.